Hello. First thing we did today was to give some names to some of the things we've been doing. So we've been looking at plates that pull apart from each other, plates that go towards each other, and plates that slide past each other. So again, just using these words, they pull apart, they go together, or past each other. And if we wanted to get it down to one word, we could say these are dividing. These are going into contact. They're gonna touch, so they're gonna contact each other. And these are kind of like almost like people passing in the hallway, like transition time. So we're gonna put that in there. And the reason I'm doing this here is to help us remember what the words are. So the science words, so the science terms for these types of plates, this is called a divergent boundary. So the reason I did this is because I could see the div for dividing and div for divergent. The ones that are going to go into contact, we underline the CON there. Those are known as convergent plates. They come together. And this was a student idea. It's kind of like people passing in a hallway, so they call it transition time. And those are called transform plates when they slide past each other. So in the future now, we want to start using these science terms. So if we talk about plates going away from each other, we want to start using the word divergent. If they're going to come together and collide, we want to use the word convergent. And if they're going to pass each other, we want to start using the word transform plates. Okay, so that's just a change. So that was one thing we did. So we're going to look at some cause and effect. So we can always usually see the effects. So we're going to put those over to the right-hand side because that comes later. And some effects that we've seen have been mountains shrinking. When we looked at those cards with the 6 different mountains on it, we saw mountains moving, like Mount Everest. This would be like Mount Mitchell. So mountains were moving across, and then we had mountains growing like Mount Everest and a couple of the other ones. And we were trying to think about, what was the reason why they were moving in the first place. And some people said plates and earthquakes and volcanoes. And we said, well, what happens if we go even further back? Like, what's making those things happen? So we came up with the idea that magma. So magma starts everything. And then we have plates moving. And the way to kind of represent this and show our thinking is that magma causes plates to move. So here we got our effect. So over here we have our cause. So the cause is magma. It leads to plates moving. So we can draw that with an arrow. And then we said, well, if these are happening, so maybe a plates moving are causing that to happen. And we haven't figured out why things are shrinking. But we do know that plates moving can make mountains move. So they'll cause that. And then plates moving can make mountains grow because of the pieces of foam kind of getting pushed together. And then we also talked about earthquakes and volcanoes. So we put earthquakes there. We can put volcanoes down here. And we're trying to figure out, are these things causes? So do plates cause earthquakes, and do plates cause volcanoes? And then do earthquakes cause mountains to shrink and volcanoes to do all these things? So we kind of took an in-depth look at this, and we said, well, plates cause earthquakes, because that's the plate boundaries. So we can draw an arrow there. But plates moving they can cause some of them, but not all of them. So it gets kind of a little, can cause some. So we'll put that in there. So we'll kind of do some dotted lines to show that it's not a cause and effect. It's kind of like a connection. But plates do cause earthquakes. And then we kind of looked at, well, do earthquakes cause any of these things that happen? And we haven't found out about shrinking yet too much. Earthquakes making mountains move as a possibility. I'm not sure if it's a causation, so we can do that with a dotted line. So there's a connection at least. So we'll at least put a correlation. And mountains growing can also be a correlation here. We don't know if it's a causation, but there's a connection. And then volcanoes can definitely have a connection to mountains growing. But not all mountains, so that's why we don't want to do causation. It only affects itself. And then we can also do one up here too. So mountains going to mountains shrinking. So that's a correlation also. And what I'm going to do is I'm going to make this a different color so we can actually see what's happening here. So I will do one color. I'll do these. Let me grab a different color altogether. I'm grabbing something that's kind of similar, so I'm going to grab a good green one here. So we'll do green. Okay, so we got the green dots there and green dots going up here. Okay, so you can see where those going, and then we will do a blue. No, I'm not going to do a blue. Blue's going to be kind of hard to see. We'll do a red. So we'll do red for the earthquakes. Okay, so you got those there, and then this one going down here. So those are the correlations. So the dotted ones are correlations, the arrows are causation. So we know those are happening because of the thing here. And we just want to do this because when we start thinking about things, it's easier to kind of follow a flow chart, how one thing makes another thing happen, which causes another thing to happen. And maybe we'll find out some more information. We can add it here or maybe over here, and we can kind of figure out how it's all connected. So we're just kind of showing connections between all these events. We have mountain shrinking, and actually what I'm going to do, I'm going to box these things in here too, so we can see our words a little better. So these were the effects: the mountains moving, the mountains growing, and the mountains shrinking. There we go, that's a little better. And so that was what we did in class.